All right, guys, here we go. Let's get started. You're doing your weathering and or just weathering notes today. We're going to learn about the two types of weathering. I'm also eating dinner, so if you hear some crunching, that's what's going on. This isn't necessarily for us. We're not doing vocab either. Here are some bell ringer questions for you to see if you remember what we did the other day, yesterday and Monday. What are the three types of rocks? Hopefully the words sedimentary, igneous, and metamorphic are running through your brain right now. Which rock is created from magma? We know magma or lava links to igneous rock. True or false, the rock cycle is linear. False, the rock cycle goes all over in any kind of directions, kind of like the path of a mouse. Challenge question, what's the difference between weathering and erosion? That's what we're going to find out today. Here's where we're going. Let's talk about weathering. Weathering is one of our processes that modifies or changes the lithosphere. It happens at or near the Earth's surface and causes rocks and minerals to break down. So basically, we're taking a big rock and we're breaking it into smaller sediments or smaller pieces. This is a key process in the formation of our sedimentary rocks. Remember, our other type of rock must be broken down into teeny tiny small pieces before it can be compacted and cemented and turned into a sedimentary rock. So this is really important. But did you know that there are two different ways or two different types of weathering? The first type we're going to learn about is called physical weathering. This is where rocks are broken down into smaller and smaller pieces, but the key here is that the composition of the rock remains the same. No chemical reaction happens here. It's like if we're breaking something, again, into smaller and smaller pieces. So I'm eating a tortilla chip right now. If I were to just bite the tortilla chip, or if I were to crush it in my hand and it just become tiny pieces of tortilla chip, that would be physical weathering. We have 5 different quote-unquote ways that a rock can be physically weathered. The first type is what we call ice wedging, which is right here, or frost wedging. And this is where water seeps, so liquid water, seeps into the cracks and rocks and expands when it's frozen. This expansion is strong enough to break the rocks. Now, frost wedging, or freeze/thaw, happens over a really long period of time. So it's pretty, it's not likely that during your first freeze you're going to break the rock, but as the rock has water in it, the crack, and then it freezes and expands, the crack gets a little larger. And then when it thaws, the water goes down even further, and then it freezes again and expands, and the crack gets a little larger. So this is something that takes a lot of time. And the end result is the rock breaking into smaller pieces. Next, we have, just as our freezing temperatures can cause rocks to break apart, our warm temperatures can cause rocks to break apart as well. The heat, if it gets hot enough, can actually cause rocks to expand if it's exposed to a lot of heat, or contract if it's exposed to not a lot of heat. And then as these molecules are moving closer together, if they're contracting, and moving further apart, if they're expanding, it can cause breaks in the rocks. That doesn't happen as often as our other types of physical weathering. The second type, or the third type of physical weathering, is due to plant growth. So some plants can grow roots into or on our rocks, and these roots can stress or even crack our rocks apart. So if you imagine as the plant grows, it's stressing. Now, there's no chemical reaction here, but it's just the physical growth of the root, just like the physical growth of our water when it freezes, stresses the rocks and can break them into smaller and smaller parts. If you look down at wind abrasion here, and abrasion is an important word, so remember that. Wind abrasion happens when wind carries particles that sandblocks rocks as they move. We can generally have just regular abrasion, and that's anything that's hitting a rock and causing it to get smaller. So like if my hammer hits a rock, it's abrasion. If a lot of feet hit a rock, it's abrasion. If another rock hits a rock and they break apart, it's abrasion. But this one we're specifically talking about is called wind abrasion because the wind does it. And if you've ever been on the beach on a really windy day, you can feel the force of the sand as it hits you it hits your body, and it can cause the rocks to slowly weather away or become smaller and smaller pieces. The last one is probably one of the most common, and it's running water. So as water moves past rocks, they can quickly break into smaller particles due to the friction of the water molecules on the actual rock. So running water can even physically weather our rocks. Again, weathering is breaking a rock into smaller and smaller pieces. When we're talking about physical weathering, we're just breaking our pieces apart. We're not changing the chemical composition, and there's no chemical reaction happening. All of these are physical factors. That's why we call them physical weathering. Like again, when I break this tortilla chip in my hand, it is physical weathering, physical weathering, because I'm just breaking it into smaller and smaller pieces. I'm not changing the chemical composition of my chip. In contrast, we have chemical weathering. Now, if you look up at the top there, you've got the definition. This is where a chemical reaction happens, which breaks down the bonds that hold the rock together, forming a new substance. So key here is new substance. A chemical reaction happens, a chemical change happens. Chemical weathering often happens in places that have more water and are warmer in temperature. That's because water often carries other things besides just water molecules. You learn about this in 8th grade, and we talked about it a little bit in Earth and Environmental Science. And warm temperatures are often very conducive to some of our chemical reactions here. They give it the extra energy it needs. The very first one we're going to talk about is oxidation. Anytime you hear the word oxidation, you should think rust, because that's what it is. It's the fancy word for rusting. This is the reaction of rock minerals with oxygen. Iron concentrated rocks oxidize. They undergo a chemical reaction, oxidation, or rust, when water, iron, and oxygen combine. So we're getting a chemical change there, and it's becoming a new substance. Hopefully you've all seen rust before. It's like a red color, often looks brittle, like it's breaking apart. Our rocks can do this too if they have a lot of iron in them. The next one we're going to look at is called carbonation. This is the reaction of rock minerals with carbonic acid, which remember we talked about is when carbon dioxide mixes with a water molecule. Rain can become slightly acidic by absorbing carbon dioxide in the atmosphere. Again, acid rain. So carbonation is actually acid rain happening. We talked about that in our very last unit. So just like when our acid rain is falling and breaking apart our statues and different rock structures, carbonation is happening. The reaction that the carbonic acid has on the rocks, breaking them into smaller pieces, and it can dissolve some of its mineral contents. But that's called chemical weathering, again, because a chemical reaction is happening between the carbonic acid and the rock. The last one is called hydrolysis. Hydro means water, lys means break apart. This reaction of rock minerals with water. The water changes the composition and the size of the minerals in some rocks, making them easier to break apart. So again, we have that changing of composition, which is why it constitutes or fits our category of chemical weathering. Again, chemical weathering, I'm creating a whole new substance. So that's like if I took my tortilla chip and I mashed it up with some queso, and I would be changing the chemical composition of my chip because I'd be adding queso. Okay, there's a couple other chemical weathering things that happen. So these are 3 of them. But other things that can happen, sometimes when living things live on rocks, like lichen, the acid in the living thing can actually break down our rocks too. So just like our roots, they can physically weather a rock. Sometimes the roots of plants can chemically weather the rock too, because the acid in the living things breaks down and changes the chemical composition of the rock, making it easier to break apart. So that happens as well, and that's something that we haven't quite looked at yet. Okay, now I'm going to introduce you to your next activity. So today you not only had to do these notes and turn them into Canvas, you also need to do the autobiography of a rock. And hopefully you haven't done it yet. If you've already done it, please go back and resubmit it after you've done this notes, because it's not going to do you any good. this after the notes. So now that you've learned about the different types of weathering, let's see if you can identify them in a story. So we're going to look at this worksheet. It's called Autobiography of a Rock. You're going to go here, make your own copy of Google Docs, yada yada. The directions say, the autobiography of Grant Stone, the first rock to learn to talk, has just been published. Grant has had a really interesting life. Below are some of the excerpts from Grant's autobiography. After you read each excerpt or little piece, decide if Grant is telling a story about mechanical or chemical weathering, and circle the appropriate work. Then, in the space provided, identify the cause of weathering. Is it abrasion, acid in living things, acid precipitation, ice wedging, or oxidation? And I am thinking I probably better bold and underline this. Otherwise, I bet you guys are going to miss this. So, you're doing that. Okay. So, you're going to read each of these little excerpts, and you're going to decide if it's mechanical or chemical weathering. So, for example, in my youth, I was part of a much larger rock on the mountainside. In the summer, small trickles of water would enter my cracks in the surface. In the winter, the water would freeze. The cracks grew larger until I eventually broke off the granite outcropping. So the first thing you have to do is identify whether it's chemical or mechanical. Because we don't have a chemical change in the rock, it's just breaking, we can label that as mechanical. So we've done step 1. Step 2, to get your second point, you need to identify the cause of weathering. So it wasn't abrasion, things weren't bumping into one another. It wasn't acid in living things, because we don't really have any living thing that's living on the rock that we know of right now. It's not acid precipitation, because it didn't talk about like acidy rain or rain that hurt. It is in fact ice wedging, because we've got the water entering the surface, and then in the winter it would freeze. So it is ice wedging. And we know it's not oxidation because it's not chemical weathering. So that's how you'd answer number 1. Now you're going to do the rest on your own. This is graded for credit, so make sure you take your time and really think about these, okay? Everyone is going to have an answer to A and B, so don't skip any of those. And some of these you'll use twice. Have a good day, guys.